The role of vitamin B12 in human health is frequently framed in terms of energy, nerve integrity, and red blood cell formation, but quietly embedded within its biochemical repertoire is a subtle influence on our sleep-wake cycles, a relationship that remains underexplored despite its growing relevance in a society plagued by insomnia, circadian misalignment, and chronic fatigue. The connection between B12 and sleep is not just theoretical. It taps into a deeply conserved neuroendocrine pathway involving melatonin synthesis, light sensitivity, and the regulation of biological time. Yet this avenue of B12's influence is rarely emphasized, leaving a potentially valuable therapeutic insight in the shadows. At the core of this connection lies melatonin, the hormone secreted by the pineal gland in response to darkness. It is the molecular signal that tells the body it's time to sleep. The synthesis of melatonin depends on methylation pathways in which B12 plays a crucial role. More specifically, B12 facilitates the conversion of norepinephrine to melatonin via its role in supporting acetylmethionine, SAMe, the body's universal methyl donor. A deficiency in B12 may impair this process, leading to suboptimal melatonin levels and fragmented sleep architecture, particularly in populations already prone to circadian rhythm disturbances, such as the elderly or those with neurodegenerative disorders. What makes this even more fascinating is B12's potential ability to act as a chronobiotic, a substance that can shift the phase of the circadian rhythm. In several small human studies, high-dose methylcobalamin, a neurologically active form of B12, was shown to advance the sleep-wake cycle in people with delayed sleep phase syndrome, DSPS, a condition where individuals fall asleep and wake up significantly later than normal. These findings suggest that B12 doesn't just support sleep indirectly through melatonin synthesis, but may also influence the master clock in the suprachiasmatic nucleus of the brain, which governs our internal sense of time. Furthermore, B12 appears to interact with light-sensitive processes that regulate circadian rhythms. Animal models and early human data indicate that B12 may enhance the brain's sensitivity to light cues, an essential component of healthy sleep regulation. In theory, this could make individuals more responsive to morning light exposure, promoting wakefulness during the day and improving melatonin release at night. This dual effect, supporting melatonin biochemically while improving circadian responsiveness behaviorally, positions B12 as a subtle but potentially powerful modulator of sleep health. Yet despite these promising insights, B12 remains largely overlooked in the context of sleep medicine. Sleep disturbances are routinely treated with sedatives, cognitive behavioral therapy, or melatonin supplementation, but rarely with nutrient assessment. Even though a deficiency in B12 may underlie poor sleep quality, daytime fatigue, and circadian disruption. This is particularly concerning for shift workers, older adults, or individuals with depressive symptoms, all of whom may already have compromised B12 status due to poor absorption, low intake, or chronic stress. Another intriguing area of emerging research involves the potential use of B12 in neurodegenerative diseases such as Alzheimer's and Parkinson's, where sleep fragmentation and circadian disorganization are common. Since B12 supports both neural function and circadian rhythm stability, it may help mitigate some of the sleep-related symptoms that worsen cognitive decline. While large-scale trials are still lacking, preliminary observations suggest that B12 repletion in deficient individuals can improve sleep efficiency and reduce nighttime awakenings, possibly by stabilizing brainstem neurotransmission and pineal gland output. The versatility of B12 as a therapeutic tool in sleep disorders is further enhanced by its favorable safety profile. Unlike sedatives, it does not carry the risk of dependency or cognitive dulling. Unlike melatonin, it does not create tolerance with long-term use. And unlike many prescription sleep aids, it has positive rather than suppressive effects on brain function. For individuals with subtle sleep-wake rhythm disruption, daytime lethargy, or chronic insomnia resistant to conventional treatment, evaluating and optimizing B12 levels may offer a surprisingly elegant solution. Ultimately, the story of B12 and sleep is one of quiet potential, a nutrient better known for its hematological and neurological roles, yet intimately connected to the biological timing systems that govern rest, repair, and mental clarity. The modern epidemic of sleep dysfunction calls for broader and more integrated thinking, where vitamins are not merely support players but active agents in restoring circadian balance. Vitamin B12, with its methylation power and neurochemical reach, may be one such agent, waiting, like a buried timekeeper, to help recalibrate the rhythms that modern life has pushed out of sync.